name is Stacy Smedley. I'm currently the executive director of a nonprofit called Building Transparency. We're a 501c3 in Seattle, Washington, but really do work globally. And our mission is to provide the free open access tools and data that is necessary to reduce embodied carbon emissions of construction. So we live and breathe in this stuff all day. We are the home of the EC3 tool, or the embodied carbon and construction calculator tool that we use to really support the adoption of embodied carbon accounting. And we also use the database of environmental product declarations to support policies across the US at the UN level, and also for the government of Canada. So we're engaged to try to help kind of really catalyze this and move it quickly. Before that, I was in construction at Skanska, and before that, I was an architect trying to design green buildings. To my left, I have Ryan Zizzo. He's currently the CEO and founder of Mantle Developments. He, a Toronto-based climate change consultancy focused on climate-smart infrastructure and buildings. Mantle Developments helps projects go beyond energy efficiency, incorporating resilience and life cycle approaches to make projects future-proof and net zero carbon ready. Ryan is a recognized leader in helping large organizations and governments transition to a low-carbon future. He has led several major projects on embodied carbon and life cycle assessment, including with the Government of Canada, the City of Toronto, and several provincial ministries working to reduce their carbon impacts. To his left is Ignacio Cariaga. I hope I pronounced the last name right. I think I've never said your last name, although we've been working together for a long time. As a civil engineer with over 25 years of experience in companies leading the cement and concrete construction industry. As commercial sustainability director with Heidelberg Materials, Ignacio is leading a team that is helping stakeholders throughout the concrete value chain to reduce embodied carbon in the built environment. Ignacio is co-founder of the Carbon Leadership Forum in Alberta, Canada, CLF Alberta Hub, and represents Heidelberg Materials and Materials Can, the Carbon Action Network, hosted by Building Transparency, to help prioritize actions around the smart reductions of embodied carbon in building materials. He is currently leading the commercial sustainability strategy in North America for the first full-scale carbon capture, utilization, and storage project for cement in Edmonton, Alberta, which will ultimately result in net zero cement without buying offsets. So I'm very lucky to have these two on this panel with us as we dig into scope 1, 2, and 3 emissions and the role of embodied carbon in construction in that accounting, and really hopefully leave you some inspiration and insights on how we can move forward faster together. So I'm going to start with a very brief scope 1, 2, and 3 introduction. I think it's been brought up in other sessions today. So there's some of you that this is going to be repetitive, but really when we're talking about corporate accountability and reporting, scope 1, 2, and 3 is how we define that. Scope 1 and 2 are largely process emissions at the plants or facilities you own, the vehicles that you own, the energy that you consume in your buildings. Scope 3 is everything else. So when you're talking about everything that we purchase for our businesses, for the work that we do, or even as consumers, if you're thinking about your own scope 1, 2, and 3 footprint, everything that we make and that we buy is scope 3 for most of the companies that are reporting. And what we've seen in recent years, as companies have made commitments that include scope 3 accounting in their zero carbon targets, Meta says they're going to be zero by 2030, including their supply chain in scope 3. Microsoft, Amazon are all in the 2040s. They are now accounting for these emissions using imperfect data, but still it's showing them that scope 3, these embodied carbon emissions of really any product, are 80-90% of their footprint. And if they're going to get to zero, they're going to have to figure out how and invest in ways and strategies to get there. So the private sector has really kind of opened up the door when it comes to just understanding how big these scope 3 emissions are. Where the built environment comes in is the fact that if you look at purchased goods for companies that I just mentioned, they build a lot of buildings and they buy a lot of concrete and cement and steel and glass and all sorts of other building products. And building products alone are over 11% of global greenhouse gas emissions. Within that scope 3 bucket, they make up a lot of the emissions of these companies. So that's kind of my brief introduction into why it's becoming so urgent through the lens of the accounting methods. But we're also seeing an awakening and an awareness within the industry and the AEC community and owners building buildings, just trying to understand how to reduce this urgently because we're running out of time. So I'll stop there with my little 1, 2, 3 spiel and move on to some questions for these two. So Ryan, in your role at Mantle, you are deeply engaged in helping both public and private sector companies account for these embodied carbon emissions of the construction industry. So I've talked about the awareness and kind of the move towards more accessibility to tools and data and more policies and an urgency around this. what has been causing this urgency? What have you seen in terms of response in recent years and the work that you're doing?
Yeah, thanks, Stacy. We've seen a big shift in the past 5 years, for sure. Like 5 years ago, I mean, Stacy and I were having this conversation, but it was definitely not, on the same level with so many people having heard about it and being, taking action on it. And I think one of the interesting things I've seen is that when people start looking at their Scope 3 emissions, they end up finding out new things that they didn't even think that they were going to be, it uncovers new things that they weren't looking for necessarily. So one example of that is we're working with one of the largest developers in Toronto, putting multiple dozen condos up across the Toronto skyline. And they came to us because they wanted to better understand their Scope 3 emissions. And we all thought that was going to look like, concrete, rebar, and those are obviously on the balance sheet, but something that it kind of shone a light on, I guess, that wasn't really on the radar when they started the conversation was one of the categories of, we saw 15 categories of Scope 3 emissions earlier. One of them is the end of life, or not end of life, sorry, the total life cycle emissions of a sold product. So if you're selling something, it's all the emissions that sold product uses over its whole lifetime. And for this developer, that sold product is the condo building, right? So they used to say, oh, it doesn't matter to us what kind of electrical system we put in, what kind of heating system we put in, because we're just going to sell the building and it's not our emissions at that point when they were only looking at Scope 1 and 2. Now that they're looking at Scope 3, they have to account for 60 years of that building being operated with inefficient systems. So that was a really interesting example of where looking at Scope 3, we knew we were going to be talking about concrete and steel, but we didn't necessarily know that we were going to be talking about more efficient systems that they were putting into their buildings. So I would just recommend people to go into your Scope 3 analysis with an open perspective and be open to finding new things and learning better ways that you can reduce, not just on your materials, but there's a lot of other things associated with Scope 3 as well.
Great, thank you. Ignacio, as a manufacturer of cement and concrete, one of the high-emitting materials in the construction sector that folks are trying to decarbonize, have you seen the demand for data and really just action on decarbonization of cement and concrete change and increase in the past 5 years, that same time period that Ryan mentioned?
Yes, and thanks, Stacy, for the question. In short, absolutely. I mean, I often talk to a lot of people, and people say, construction industry has always been very stagnant in developing new technology. There hasn't been so much evolution in technology, but I think this last 5 years are proving people wrong. And it's not so much the construction industry making this, it's more of the sustainability aspect in construction. So in particular to your question on the cement and concrete, I will say that the cement industry and the concrete industry has had a lot of initiatives beyond 5 years or 10 years ago. We had seen the first sort of the Portland limestone cement as a big initiative a decade ago. And so that proves that, we were making the right steps 10 years ago. However, as we know, transparency is the new green. And the fact that we started to make an emphasis on making sure that people become more transparent about what they do and how they're doing it became evident. And that's where we saw the big wave come. And you can probably attest if you go to the EC3 tool, you can see the number of EPDs are generated. And it's all coming back to one key element, which is education.
Before you go on, can you explain what an EPD is? We have so many
Sure.
three-letter acronyms in this space that it's always good for us to give the full definition. So we aren't sure how many people know all the three-letter acronyms yet.
Absolutely. Environmental product declarations. And an environmental product declaration is similar to a nutrition fact label. When you look at anything consumable, a milk, a cereal box, anything that you buy to consume, it's got a nutrition label. And that nutrition label informs a person that wants to procure something with sort of a more health consciousness and nutritious consciousness to look at calories and so forth. So an environmental product declaration is no different. This is what we call an EPD, and that EPD has a label which shows the carbon footprint of the product. And typically it's measured in global warming potential. That's what we call GWP. And that shows and measures the kilograms of CO2 equivalency per unit of the material. In the case of cement, it's per ton of cement. In the case of concrete, is per cubic meter of concrete. In fact, in the case of a total finished building, the carbon intensity is also measured in kilograms of CO2 per square foot or per square meter of the building. So just to wrap up my comment is the whole wave of EPDs came on board, and the fact that we have the last 5 years was totally focused on education allowed us to make sure that there's one thing is clear. What gets measured gets managed. And that's where we started to see the needle move. Because now people saw, oh, there is a carbon footprint there. Now that we know what it is, let's deal with it. Before, that was just people doing the right choices, but without being able to measure it. And that's why I think the 5 years was the catalyst, was the transparency.
Thank you for that. I'll just give you the one stat on EPDs because we have all the data from EC3. When we launched the tool in November of 2019, we had, I think, 1,800 ready-mix EPDs for concrete mixes, and now we have 120,000 ready-mix EPDs for concrete mixes from places, largely North American. We're starting to see them in Australia, Europe, and other markets. So the catalyst and the scale really, I think, drive the demand on our side, just on the data accessibility. But I want to ask both of you, so we have the transparency. The next step is, I think, the mechanisms of requirement of reporting and compliance. And I would wonder, starting with maybe Ignacio, you, because you've had to respond to some of these in the past handful of years, where is that compliance or that regulation coming from right now already? What are examples of places that are already kind of operationalizing this at the government level or at the private level?
Sure. I think what the biggest demand at first was more voluntary. You had the big tech companies. It was more driven by ESG, as we've heard today, a lot of ESG. That was sort of the catalyst where it was pushing the envelope and having voluntary project requirements and specifications around, first of all, having EPDs, then talk about GWPs and so forth. But on the compliance side, there is actually some movement. It's already catching up. You've seen cities, a perfect example, the city of Vancouver, leading the way in terms of creating embodied carbon policies. And one that I would emphasize that is strictly driven by performance, not prescriptive, performance specifications where they're putting out some terms in the outcome, what we'd like, the policy would like to see as an outcome in the performance, not necessarily to prescribe, the recipe of how to do it. Compliance requirements at both federal, provincial, or state level have been evolving, and it's growing rapidly. Who was to say that City of Edmonton was going to have an embodied carbon policy? Right now, it's being created. When I had the honor of co-starting the CLF Alberta, we had a lot of conversation, a lot of education to foster conversation with City of Edmonton. And right now, there's already an embodied carbon policy in the City of Edmonton. And again, I can't emphasize enough that this is not just a top-down approach. This is a both bottom-up approach. And it's like the people in this room that will make the difference and start the conversation so that cities get on this. There's models that you can replicate and just copy and paste in different cities. And the faster and the sooner we do this, the better we'll be.
Yeah, maybe I'll just add to that, to give an example from Toronto, where I'm from. I worked with the city to help update their Toronto Green Standard, which is the requirement for new construction at the design phase. And we updated their embodied carbon strategy around that to actually put in a cap on the embodied carbon intensity of new construction in Toronto. Currently, it only applies to city-owned construction, so fire halls and childcare, so things that the City of Toronto actually owns themselves. But it's a tier 2, which is a voluntary higher level strategy for non-city construction. And there's a plan that the tier 2 things become tier 1 and become mandatory in a few years, right? So the plan right now is in 2025. Everything that's currently at tier 2, so this embodied carbon cap on general commercial construction, that will then become required in 2025, and you need to do that to get your building permit. So right now that cap is 350 kilograms of CO2 per meter squared. It's an actual number, and so people need to start taking this really seriously, or else if they're not able to show that they're below that threshold, and by 2025, if everything goes according to plan, they won't be able to get a building permit. So we're seeing this move from voluntary, nice to have, to very short order. It's going to be table stakes for getting your building permit, just like energy modeling is. I like to tell people, when I started my career 15 years ago, energy models were nice to have, right? Maybe the project going for a LEED certification might do an energy model, but most projects didn't do it. And now it's just, standard. Whereas I think that's the exact same thing is happening with life cycle assessment now, that in the next few years, we're going to see it be table stakes for high performance construction.
Great. And there's two kinds of embodied carbon accounting that we talk about. There's whole building life cycle assessment, and there's low carbon procurement. And both are absolutely necessary to actually decarbonize along the entire value chain of your project. I think for this panel, since we're talking about impacting subtrades and really digging into that component.
Can I just,
yes, go ahead. Yes.
The material, I want to give an example of a Canadian example
great.
for the second option you said, which is material specific, right? So the federal government has a standard on embodied carbon in construction that was just released this year. It just came into effect in January. And it says you need to have concrete that's 10% below a threshold. So that's an example of a material-specific embodied carbon requirement, whereas the one I gave before for the City of Toronto, that's the whole building intensity. So those are two different models, but both of them are very useful, and we're seeing both roll out across the country.
And they can be done together. It's a kind of a one-two punch of designing as best you can, reporting on that, proving that you did it, and then for Scope 3 accounting, where you need realized numbers with emissions factors and the material quantities using the procurement method and the EPDs. And you're decarbonizing material by material.
Sorry, Stacy, could I add one more thing?
Yes.
When we started to look at this, a lot of customers, a lot of concrete suppliers started to understand, and they said, well, this is still voluntary. I'll just wait until it becomes compliance. And so my message to that sort of segment is, well, we can choose today if we want to be driven by carrot or by stick. And I would argue that right now there's an opportunity for everybody to become more proactive and be led by a carrot versus a stick. And people are still talking about until it doesn't become building code, I don't have to worry about it. Well, guess what? Government of Canada already started to talk about building code changes. So embodied carbon will be language you will see in the building code. In fact, there's a date, I believe, of 2025 when that building code is going to be in effect. 2030. Thanks.
Too long. Needs to be quicker than that. We'll see if we can accelerate it.
We should just have you come up here. I'm just kidding. It's another expert over there if you need help with any of this, especially in Vancouver. So I wanted to dig a little bit in. We talked about the two different types of policies. I think when it gets in, we have Ignacio here representing cement and concrete. So Ryan, I guess digging into that kind of low carbon procurement, environmental product declaration space. We talked a little bit about the policies that are coming, but how do the AEC, the architects, engineers, contractors that are actually having to then kind of meet the requirements for their owners and be the ones that are becoming the experts in how to account for this, how are they leveraging tools, EPDs? How do they do the work? What are you seeing in terms of that ecosystem? What are the pathways for them to be able to actually support those policies? Mm-hmm. I think we have some contractors, at least in the audience.
Yeah, the biggest challenge is actually something that shouldn't be a big challenge. It's getting the quantities of the materials that go into the building, right? That's the first thing that we need when we are going to do an assessment. We say, how much concrete do you have? How much steel do you have? How much rebar? How much mass timber? How much insulation? And those numbers are not readily available, right? So that's something that we can do if we just put that into our accounting from the start and say, at the start of this project, we're going to be doing a continual carbon accounting on our materials. So all the design teams need to have a running tally of what your current design's material quantity is. If we set that from the start, it's easy, right? We can use BIM, building information modeling, 3D modeling. We can use those to, if that's set up from day one to use it, take a quantities out of, then you just say output quantities, right? And it's very simple. So that's something that I would recommend everyone when you're starting a new project, make it clear to everyone that there's going to be carbon accounting on the materials. So we need a running total for the material quantities. And then once you have that, you use a tool like EC3 or One-Click LCA or Athena or Tally. There's a bunch of tools out there, or Beam for if you're doing smaller residential construction. And you use that tool to basically map each of your material quantities to a carbon footprint. Typically that's from an EPD, right? You link it to a specific EPD. It could be a actual manufacturer's EPD that you might procure from, or it could be an industry average EPD for typical Ontario concrete, for example. So that's basically how you do it, and then you need to iterate that throughout the design. So it's not really super useful if you just do that one time, but it's about doing that and then using it to find the hotspots and find lower carbon opportunities.
And I'll just talk a little bit. I mean, this is how it came to be something that I was looking at, because I was in the estimating department at Skanska. And if you think about how estimating flows through a project, you're looking at average costs or ranges of costs against products and material choices during design. You're getting to a DD estimate, a CD estimate, and then you're actually procuring materials and looking at the cost of each of your choices for each material. If you just think about carbon the exact same way, it becomes something that people can kind of sit in their minds. You're using averages or ranges during design because you don't know the actual product or manufacturer yet. And then during construction, you can actually ask for the environmental product declaration from your 3 choices, make an informed choice on cost and carbon, and then account for the actual cost of the carbon emissions at the end. So it's exactly right, Ryan. I think it's just getting it into the thinking that it's not a crazy new concept. It's just a different unit of measure than cost, but the exact same process.
We've started using that same costing languages in terms of calling it a Class D LCA when we're at the schematic design phase, right? Because sometimes people think, well, I can't do an LCA until I have perfect data and know exactly where everything's being shipped from. And you can wait until you have all that data, but you can't really make any changes if you wait until then, right? So it's all about finding the sweet spot of when we have enough data to an estimate that we can actually use to make a better decision and a lower carbon decision. So let's do a Class D LCA. It's not going to be perfect, but it'll be useful, right? And it'll help us directionally get to a lower carbon solution.
I think, Ignacio, for you, just following that chain of how do we do this? I think, we've got the policies that are coming that are requiring it, whether it's private policies because of their scope 3 targets or public policies. We've got the AEC professionals that then have to actually do the work to give the results to the owner. And then we have the manufacturers that actually have to provide the data through the EPD process. And can you just talk a little bit about what that process looks like? Has it gotten easier than it was a handful of years ago? I think, Heidelberg was one of the first to really invest in this on the project that we were piloting on in Seattle. You were chosen for Microsoft to really help them push this forward when it was early days. So what has your journey looked like, and what would you say to other concrete suppliers in terms of how to engage in that particular process?
Sure. Thanks, Stacy. For sure, in terms of being a manufacturer, I'll speak to 2 products that we make, cement and concrete. For cement, it was quite easy because we only make 2, 3, maybe 4 cement products in our facility. But on the other side, you have concrete, and concrete produces probably 300 different products every day. And the fact that you can perhaps change an admixture or reduce the air, the water, change the water to cement ratio. Because it might be raining, you might want to change the mix design a little bit. Every time you change a mix design, guess what? It's a new product. And that requires a new EPD. So when we first explored this, and we found that it would be extremely expensive, cost prohibitive, because you were now generating EPD for every mix design you have. Every batch plant will have probably 300 to 500 different mix designs. It would become very expensive very fast. However, the technology has been evolving in the way that there's companies now that can generate what they called EPD on demand, environmental product declaration on demand, which is basically the way that I'm going to go back and share how you create an EPD first. So an EPD is basically the carbon footprint from what we called an A1 to A3, meaning from cradle to gate. From when we extract the raw materials that we use in the production of our products, we include everything that we had to do and use when we extracted that raw material. Then you account for the transportation of that raw material. And then you account for the actual manufacturing process. Everything that was involved, including your scope 2 emissions, which is your electricity. When you add up all A1, A2, and A3, and you get the data that you've collected through an LCA, life cycle assessment, you collect that information, and that makes up the core of the EPD. That EPD then is gone through a third party, a operator that will go through a third party verifier, completely outside of the realm of the company. A third party verifier will evaluate the assessment, the life cycle assessment, and then verify that EPD. So the huge, I would say, uphill battle of cost was a barrier that was overcome quickly when we had companies that would generate the EPDs on demand, because all that data were already backed up as a life cycle inventory data. You just, every time you change the quantity of the product, the data was still in the background. You just change the dose, then the system will still feed the data according to the different material quantities. And therefore, you could generate an EPD on demand. As soon as you make the switch on the mix design, you can generate a new PD immediately.
Yeah, and we were watching this space. Again, that's that big trajectory for the EC3 database. This EPD generators, this on-demand approach, enabled suppliers to get one cost. I think the things that I've heard recently is $1,500 to $5,000 ish, and you could verify that, Ignacio, per plant to do the EPDs on demand for all of their mixes. So the barrier of cost used to be 25, 30K, I think, per EPD. The barrier of cost is lowering there.
And we're going to see a lot more on EPDs in the near future. The IRA, Inflation Reduction Act in the US, they put hundreds of millions of dollars towards funding EPDs.
$250 million for an EPD grant program for the manufacturers of concrete, steel, asphalt, and flat glass to start, where they're just going to pass through money to the manufacturers to cover the full cost.
Yeah, and I was in Ottawa a couple of weeks ago and asked a few senior people, when is the Canadian version of that coming? And they said, we're working on it. So I think in 2024, we're going to see some funding for Canadian manufacturers to create their own EPDs as well. So if it's not on your radar and you're working with manufacturers, it will be very soon.
All right, we're going to move on to the next question. So Ryan, I'm going to ask you this question, and Ignacio, you'll probably pile on. But Ignacio talked about the production of EPDs and the fact that you can decarbonize these things once you have the data in some low-hanging fruit ways. But what are some things that you're seeing in terms of positive progress in decarbonizing the process of manufacturers and then installing construction products? Are we making progress on how we actually make these things already? Are we making progress on how we install them in the work that you're doing?
Yeah, definitely. I mean, I could speak to the concrete industry, but I'll let Ignacio do that. We're working with a steel fabricator actually right now who wants an EPD. And they don't actually make the steel themselves. They just order steel from other people, other plants, and put it together, fabricate it, right? And they, again, didn't start this process with the understanding that they were going to probably change their whole supply chain. But we realized that a bunch of their steel was coming from plants that was very inefficient, right? There was a huge carbon footprint for some of their steel, but some of their other steel, it was very small carbon footprint, right? Some of it, this was an Ontario-based steel fabricator. They get some steel from Hamilton, right, from down the highway, and it uses Ontario's electricity grid to put it together, and it had a very low carbon footprint. But they weren't prioritizing their supply chain based on carbon footprint until now, right? So this was a really great example of they just have to shift who they're buying from, right? They can say, you know what, we're going to prioritize this local low carbon steel, and then we've heard that at the Dofasco and Stelco plants in Hamilton, they're undergoing billion-dollar retrofits to reduce the carbon footprint of their current product even more. So we're seeing a big change in both purchasing habits and decarbonizing of the actual plants themselves. And the other thing I would say, if you don't have an EPD, if you don't have that data yet, you can start by just looking at the carbon footprint of the grid where you're purchasing your materials from, right? So one of my favorite websites, because I'm a carbon nerd, is Electricity Mapper or Electricity Map.
That's a good one.
Yeah. So if you go there, there's a color code on all of the regions where electricity is being generated, and you can see, in BC it'll be bright green because it's super low carbon, your electricity here, and in Alberta or Texas or other places where they're using fossil fuels and coal to generate their electricity, it's red, right? It can be 800 grams of CO2 per kilowatt hour in some of those places, and 2 in Quebec or in BC. We're talking huge differences in the carbon footprint. So using those energy mixes to produce your materials, if all else being equal, it's going to be a lot higher carbon in those red regions. So I would recommend people to check that out too.
Great. And then Ignacio, I think this is your chance to explain what you're doing at that facility in Canada, and I think maybe the role of the policy and the incentives played.
Sure. In fact, as Stacy alluded to, Heidelberg Materials is building the first full-scale carbon capture, utilization, storage project to a cement plant. This will be done in Alberta. And it's funny, Ryan, that you mentioned that the color code in Alberta is red. In fact, that's one of the reasons what we had to do something very unique and creative. This project is not only carbon capture, which will capture the CO2 from the cement plant. We are actually taking it upon ourselves to generate our own power, because we feel that it didn't make sense for us to be using a very carbon-intensive electricity, when in fact the carbon capture process is very energy-intensive. So we decided to generate our own cleaner power, still burning natural gas, but cleaner than what the grid offers, but yet those emissions will also be captured. So the carbon capture project in Edmonton not only will capture the CO2 from the cement plant, it would also capture the CO2 from the electricity we generate, making our Scope 2 emission zero. This will be the first project in the world to do full scale, meaning that we'll capture 95 to 97% of the CO2 emitted, and it will be permanently and safely stored in a deep saline aquifer. And that's another one of the reasons why we selected the Edmonton plant. It's located near a geological storage where we can permanently store the CO2 below grade.
Great. Thank you for that. So see, it's happening. It's not tomorrow. We have examples that are happening today, and this is the kind of thing that we need to scale. And you didn't mention the fact that, didn't you get some funding for the project?
Yeah, that's important to note. Obviously, this is public domain, so it's actually the price tag on this project is $1.36 billion. It's actually more expensive than to build a cement plant. However, Heidelberg Materials believes that this is the way of the future. Sometimes when I get asked this question about how expensive is it, Mike, the way I answer it is a different way. The way I answer it is ask another question. It says, well, how expensive is it to not build it? And let's think about the consequences. I think that we are doing the right thing, and we are very fortunate to have the partnership of Government of Canada, and also we're working with provincial government to help this project get it off the ground. And in fact, the Government of Canada has committed to reduce the industrial emissions in Canada, and this is a perfect example. 1 million tons of CO2 will be reduced by investment like this, and Government of Canada has committed to helping us on this project, both on the capital side and operational side, by putting an OBPS, output-based pricing system, to put a value to carbon in the future. And that value would set to be at $170 by 2030.
If I could just jump in, I know we're almost at time, but I wanted to just mention also, the goal really isn't to just decarbonize our materials, it's to use our materials to store carbon, to pull carbon out of the atmosphere in a bio process or even a geological process. You can create aggregate out of atmospheric carbon and turn it into an aggregate for concrete, right? So there's these solutions out there where we could actually use the building stock to store carbon, right? And it could actually be a solution to climate change, not just be less bad, but use our buildings, which is the biggest source of human endeavor by creating our cities. We can actually store carbon in those cities so we can build our way out of the climate crisis. So that's what I'm really excited about, and looking forward to more solutions where we can use carbon storing materials in our projects going forward.
Yeah, I'm glad you mentioned that, Ryan. So we have one last question. I think we have 10 more minutes, so we'll do a little last note from each of you. So we talked a lot about progress and trying to basically inspire you that there's stuff that you can do today and that this is already moving, and that there's resources available to you. But I always use an analogy of an onion. There's a saying that life's like an onion. You peel back the layer and sometimes you weep. So you're kind of digging into this. I call embodied carbon. I just replace life with embodied carbon. Embodied carbon is like an onion. You peel back a layer, there's another layer. Sometimes you cry because it seems so hard. So with those layers, right, I think we're at a certain point in this where we've peeled back a few of them and we're not crying anymore with those, but there are other things like data quality, data harmonization, tool accessibility, tool alignment, policy alignment, all these things. Just what's one thing that kind of keeps you up at night, or that we all need to be aware of as we're peeling back those additional layers of the onion?
I can start. I think I'm going to speak to two things that keep me up at night. I talked about government support. Although we're getting government support, there's still a lot more homework to do. It's not only about the capital investment of projects, it's also the procurement support. making sure that there's procurement policies in place to support projects like this. And that's something that we know for a fact. Heidelberg Materials is committed to invest in these projects, but until we don't have full commitment from provincial and federal government, it's hard to make these projects go. So that's one thing that we're still working on. It's although we are getting good indications, we're still a lot more work to do. And second is we talked about measuring and that way that we can start managing a reduction of embodied carbon. There's one element that we've got, and I think it's missing. We look at embodied carbon A1 through A3, which is cradle to gate. The one piece that's missing is during the operational of the building, which is the maintenance. There's a lot of emissions being generated by maintenance being done to buildings, replacing, rebuilding, all these issues, which we can have access to that information. That data is still missing. So that's one thing that I think we need to still do a lot more work to start measuring the embodied carbon on the life of the building. And it's a matter of us making sure that the owners of those buildings, because they own that data, making sure that that data is available for us to learn about that and start measuring it.
I'll do two as well, then I'll follow your lead. The first one is just consistency in how we're measuring and, the methodology about the calculations. Like, do we include the parking area in the embodied carbon? Is it cradle to gate, or is it cradle to substantial completion, like when the building is occupied, or is it cradle to grave when you disassemble it? Like, all of those things are going to give you a totally different number, right? So if you just look at a life cycle assessment or an embodied carbon number, you need to really dig in and say, how was that calculated? What was included? What was the scope? Because just comparing two numbers, they probably were calculated in a very different way using a different scope. And there are industry programs and government programs coming to try to harmonize that, but that's a big hairy issue that people should be aware of. And then the other one is carbon storage. I think the time value of carbon, really. When are these emissions happening? Because I don't think we're doing, as an industry, I don't think we're looking at that really at all right now. And we're just treating an emission today the same as an emission tomorrow or in 50 years or in 60 years, but that's totally wrong, right, from science. It's the amount of time that the emission is in the atmosphere for that matters, right? That's the climate impact. So we need to be prioritizing short-term emission reductions over long-term emissions reductions. And I'm trying to get the thinking out there of, let's start talking about net present carbon, right? We talk about net present value. We discount our future financial flows because we realize that they're less valuable than current financial flows, but we're not discounting our current our future emission reductions. They're going to be in the atmosphere for less time. So let's discount them in a way, or devalue them, and value the short-term immediate reductions.
Which is really what we need to focus on if we're going to meet our goals in the next 10, 20 years.
Yeah. And then if we add that, then we'll start prioritizing bio-based materials and carbon-storing materials, because we'll see that there's way bigger benefit to those short-term benefits than talking about maybe a slightly more energy-efficient system over 60 years.
Great. Okay, I think with that, we'll go for questions. I think we've got 5 or so minutes. Is there any questions in the audience? Did we amaze you or terrify you? I don't know. Sure, there's a couple. I don't know if there's someone that's running. I can run the microphone if I need to. Or you can yell. Okay.
Association. Full disclosure, I worked with Ignacio, but we didn't prepare a question or anything like that. APDs, again, very central to our industry. I hadn't heard basically the figure that you described, 180,000 PPDs for the concrete sector. I'll tell you one of my pet peeves is that there's technologies out there, I will not mention the name, but there's technologies out there, we've all heard them, they've got the silver bullet. Use them and you can reduce emissions. And I ask directly, can we see the EPD for that? Using that magical bullet in that product. And we're not able to see that. And so I guess, not just for Ignacio, for all of you, you've got experience with EPDs. How do we get more, and again, more transparent data on some of these technologies that are, I'll say, very, they're elected officials seem enamored with them. And, I'm an engineer. As geeks like me, we say, look at the EPD, but that's lost in it. How do we get that transparency in some of these evolving technologies? Thank you.
So we're working with a few of them. I mean, building transparency works kind of across all sectors with the manufacturers, folks like Heidelberg, American Wood Council, in different material categories. And we've floated this idea of predictive EPDs, where if it's a material that could follow the product category rule, or an alternative material that could follow the product category rule for something like cement, that they could go do a predictive life cycle assessment with predictive energy consumption for a plant and at least get closer to something that's following the same rules and could be directionally comparable. And that there are a couple of companies that have gone through the process of doing that. It's just how we then enable that to be published in a way that people have trust in. But there's some work on that just in terms of how we get to the right data that we need to make an informed choice for these things that haven't been in operation for a year and can prove it through an EPD process.
Yeah, I would say get the data. I mean, you keep asking for the data, right? I'm not going to just believe someone if they tell me they have a low carbon product. There needs to be some kind of an analysis to back that up. So that's why you need to verify, right? That's why Ignacio said the EPD process has third-party verification built into it. So it's not just one company saying that they have a great product. It's multiple companies that have had to look at the data and say, this is accurate, right? So I think keep asking. And if they don't have a good answer, then keep looking.
It's really, we're seeing the major technology companies that are wanting to invest and find a way to say that they're going to decarbonize through investment in some of those products be the ones that are now asking. And it's those folks that are asking that have the money, I think, the dollars to spend to invest that can push some of those novel companies or products to try to find a way.
One last thing that I would add to what Stacy and Ryan said is I think it's about education. Not only about that technology to make sure that they're doing the right thing, but it's the users and the audience. We need to make sure that everybody that is looking at those technologies, that they need to be aware of what questions to ask and make sure that how do they challenge their suppliers. Because again, sometimes you get blown away by the shiny next thing, and it sounds very sexy and it sounds very incredible. But yet you need to start asking the right questions to really know and do a deep dive to really understand what the value really is. The net environmental additionality sometimes is very minimal when you start looking deep into it.
Yeah, and sometimes stories are sexy, but the data can tell a very different story, right? So like one example I use is like if some people are all about local, right? It needs to be local and then it's good. But like you could have the example of local bananas grown in Ontario in a greenhouse, right? But look at the carbon numbers, like, oh, it's local. Does that make it good? Like, no, you use a lot of energy to heat that greenhouse over the winter, much more energy than you would have used to ship a huge thing of bananas from the tropics, right? So the story is not always the same as the data. So go for the data.
Is there any other questions? If not, I think we'll just end with that. Go with the data. And thanks for listening.
So, I'd like to add one more thing that I just remember. One of the things that, to your question, keeps up at night is, as Stacy alluded to, this is more of an accounting system, just like your estimates. When you start measuring the carbon footprint of a building, just like it cost. The one thing that I think we have some work to do is we do this as a design phase, at the design stage, to maybe get a job. To go for a tender, you need to submit these documents. I don't think we're doing enough of a job right now to look at post-mortem. What was the design and what was as built? Are we actually looking at what the carbon footprint is as built? And I think there's a gap there, and we're going to be very surprised to see that the carbon footprint as built is way higher than what it was initially designed to do. And I think there's a lot of people that need to be involved in that conversation. I just maybe as a call to action to everybody in the room to start thinking about it. How can we close the gap? Because there is a real big gap.
We call that a Class A LCA, as built.
All right, we'll end now for real. Thanks everybody for listening.
Thanks.